Hello everyone, my name is Sudheer Obbu. As a DevSecOps and multi-cloud architect, I have spent the last 19 years helping companies architect, secure, and optimize their cloud infrastructures. I have had opportunity to lead some incredible projects, from innovating GenAI-based solutions for AI apps to re-engineering high-performance payment systems. The topic I'm here to discuss today is one of the topic I'm deeply passionate about: securing our AI pipelines from development all the way to production. As we operationalize machine learning, we are creating a new kind of battlefield. The challenge is that our traditional DevSecOps practices, which we have relied on for years, simply fail to address the novel threats that MLOps introduces. We are facing an attack surface that extend beyond code to our data, our models, and our entire infrastructure. Today, we are going on a journey. We'll start with the reality that you have vulnerable ML models, but we won't stay there. We're going to move from a state of vulnerability to position of strength and creating what I call unbreachable pipelines. We will do this by looking at real proven security frameworks, seeing a security in action, and leveraging battlefield tested strategies used by Fortune 500 companies. My goal is simple: to show how to stop playing defense and make your pipelines more robust. So, how will we get there? Here are our agenda for today. First, we will define the problem by looking at the expanding MLOps attack surface. Then, we will introduce the solution, adopting the zero trust mindset, the core idea of never trust, always verify. Then, we will get the practical with the framework, applying these principles across the ML lifecycle. I will share the impact with the proven results and real world case studies. And finally, I will leave you with with your roadmap, actionable steps to get started on building truly secure MLOps environment. So let's start with the core problem. Machine learning pipelines have created a brand new security battlefield. The traditional DevSecOps practices we have relied on for years simply fail to address these challenges. Think of your MLOps pipelines like this hose. In perfect world, clean one valuable data flows it through it smoothly. But in reality, this pipeline has multiple weak points. An attacker can target your sensitive training data, poisoning it, stealing, stealing it outright. They can go after the model itself, tampering with its logic and stealing intellectual property. They can compromise the underlying infrastructure where your model is trained, or they can attack the interface endpoints where your model makes live decisions, leading to envision attack, data leakage. The attack surface has expanded beyond just code, and we need a new strategy to defend it. So let's zoom in on these hidden threats. While we still worry about traditional code vulnerabilities, MLOps brings a new and dangerous class of high risk threats to the forefront. Let's look at three major MLOps specific threats. First, data poisoning, which has staging 95 risk score. Imagine an attacker substyle feeds your fraud detection model bad data, turning your fraud detector into a fraud enabler. Next is model theft. With an 85% of risk score, this is a direct attack on your company core business asset, your proprietary models. Finally, we have interference attacks, carrying 90% risk score. This is where an attacker manipulates a live model to get desired outputs or to extract confidential information it was trained on. So, how do we fight back? The solution is a fundamental shift in mindset called zero trust. The core principles is simple but powerful. Never trust, always verify. It's a security model built on maintaining strict access controls, not trusting anyone by default, even if they are already inside your network. What does this means for MLOps? It means every single action is scrutinized. Every request to access data or deploy a model must be authenticated, authorized, and continuously verified. And the benefits is not just a theoretical. Adopting this approach has shown a cause of 73% reduction in security incidents. This is not just about better security, it's about building a more resilient and trustworthy AI systems from ground up. So it's important to understand that applying zero trust is not a single action. It's a continuous practical practice applied at every stage of MLOps pipelines. We are going to break down the implementation of zero trust into 4 key stages of machine learning lifecycle. We'll start with data ingestion and preparation, where we securely gather and prepare our data. Then we will move to model training and validation. Ensure we train our models with a strict access controls. After that, we will cover deployment and serving, where we deploy models into secure environments. And then finally, we look at monitoring and governance, where we continuously watch over our models to keep them in secure production. Let's start at the foundation, data ingestion. The goal here is to fortify your data foundation. In machine learning, we all know the phrase garbage in, garbage out. But from a security perspective, it's far worse. It's a poison in and poison out. How do we apply zero trust here? We build a data security pyramid. At the base, we'll use a strict identity and access management to enforce authentication for data sources. Next, we enforce data encryption for all data, both in transit, at rest, and at rest. Finally, at the top, we ensure data lineage and integrity. We need to be able to track data origins and transformations using checksums to verify that the data has not been tampered with. Stage 2, model training and validation. So now we move to stage 2, model training. This is where your secret sauce is created, and our goal is to secure this environment at all cost. We do this in 3 key ways. First, we created fortified training zones. Think of this as a isolated every training job in a sandboxed container to prevent unauthorized access. We then serve all necessary network access and scan every dependency. Second, we enforce the principles of least privilege. A training script should only have absolute minimum permissions to function. Read access to necessary data and write access to specific model artifact location. And the third, we focus on model artifact security. Every model that is trained should be digitally signed and versioned. Those models are then stored in a secure and audited model registry with its own strict access controls. Stage 3, deployment and serving. In stage 3, we focus on deployment and serving. This is where the model meets the real interfacing with users and other systems. So our goal is to harden these live endpoints. We start with the runtime protection. Models should be deployed on hardened minimal container images using network policies to restrict all unnecessary traffic. Then we secure the API endpoints. Every single interface request must require authentication and authorization. We also need to implement a practical defense like rate limiting and input validation. Finally, we need a secure configuration management. Things like keys and database credentials should never be hard coded. They must be stored in a dedicated secret manager like HashiCorp, Vault, or AWS Secret Manager. Monitoring and governance. Our final stage is monitoring and governance. Here, our mindset has to shift. Our goal is to assume breach and to be continuously looking for threats. Security is not a static, it's a living cycle. It starts with the continuous monitoring. We need to log every request, response, and access event across entire pipeline analysis. With the data, we perform behavioral analysis. We actively look for anomalies like model performance, drift, and data skew, which can indicate a subtle attack. When anomaly detected, we trigger automated response. Instead of waiting for a human, we have automated workflows to mitigate threats such as revoking access, alerting the security team for further investigation. So, what is the ultimate impact of all this work? Adopting zero trust framework does more than just reduce the risk. It's a fundamental build resiliency by design. You shift your entire security posture. You move from reacting to threats to building a secure pipeline that expects and nullifies them. By verifying every action and enforcing the principles of least privilege access, you harden your systems against both external and internal threats. The result is a dramatically lowering of your organization overall risk profile and leading to that proven 73% reduction in breaches we talked about earlier. So let's look at how this works in real world. Let first fintech leader. So their challenge was immense. They need to be protected sensitive financial data, proprietary fraud detection models. By implementing a zero trust strategy, their solution was to implement a strict IAM and sign all model artifacts. The result, they eliminate they eliminated all major audit findings on data access controls and reduced the time their team spent on manual compliance reporting by 40%. Next, consider a healthcare platform. Their challenge was complying with HIPAA while using a patient data for AI diagnostics. Their solution was to deploy models in isolated environments with a token-based API authentication. The outcome was a huge success. They achieved a HIPAA compliance and, most importantly, secure sensitive patient healthcare information. So this might seem like a lot, but you can begin with the journey today with 4 actionable steps. This is your roadmap to zero trust MLOps. The first, assess and baseline. Identify components in your ML pipeline and map current access controls to find high risk areas. Second, implement a strong identity. Assign unique identity to all users and services and enforce multi-factor authentication. Third, enforce least privilege access. Grant only minimal permissions required for each task. Use just-in-time access where it is possible. And fourth, monitor and respond, implement continuous logging and anomaly detection to identify and contain threats in real time. The good news is you don't have to build all this from scratch. There is a rich ecosystem of security tools you can leverage to implement this framework. For identity and access management, you have tools like Okta, Azure Active Directory, HashiCorp Vault, and AWS or GCP Secret Manager. For code and container security, you can use scanners like Sync, Trivy, and Dependent Bot. For networks and runtime security, Service Mesh, STO, or Linked can handle encryption and policies, while Falco can detect runtime threats. And finally, for data model governance, tools like DVC can track data lineage, while ML Flow or Clear ML can provide secure model results. As you start on this path, there are a few common pitfalls I wanted to avoid. First, don't ignore the human element. If you create so much friction, your data scientist will build insecure shadow IT workflows. The solution is to automate security within the CI/CD pipeline and prove secure by default project templates. Second, the set and forget mentality. Zero trust is continuous process, not a one-time setup. You must regularly audit access logs, rotate credentials, and perform automated security drills. Finally, remember to treat models differently than regular code. A signed container is good, but it doesn't prevent a model from being stolen or poisoned. You need model specific controls like digital signature for the artifact themselves and actively monitor for performance drift. So, as we wrap up, I wanted to leave you with the core 4 takeaways, which you can think of as the MLOps security pyramid. At the base, understand that MLOps attack surface is unique. It extends beyond code to data, models, infrastructure, requiring a specialized approach. The next layer is embracing the zero trust mindset. Never trust, always verify is the guiding principle to effectively secure modern AI systems. Building on that, remember that security is a life cycle, not a checkbox. You must apply zero trust controls at every stage, from data ingestion to production monitoring. And finally, at the top, know the results are proven. Adopting this framework is a strategic investment that secures and reduce security incidents. So that brings to me end of my presentation. We have covered unique threats facing MLOps and laid out a comprehensive proven framework to make your AI pipelines unbreachable. Thanks for your time. I would like to be happy to answer any questions. You can reach out to me in my LinkedIn or like my email ID. Thank you guys.